I'll do a real easy one for you, then I'll jazz it up a little bit. So basically all of this stuff really boils down to the idea that if you can get your answer just by plugging in the x value, then do it. Right? So in number 1, extreme close up. Whoa. Whatever. Look at that. Very nice. Well done. Limiting constant gets plugged into the variable. Simplify. Solve. Done. All right.
So the limit is not equal to 1?
So the limit is just the number 1.
Okay.
It is a y value though, but we just say it's equal to 1. You just plug in what it's approaching, and that's it for this question. All right, there's a reason why it's number 1 though. All right, it gets harder because all of this stuff is telling us that sometimes when you plug it in, you don't get a clean number. If you don't get a clean number, it could boil down a couple of different ways. One way would be if you got something that's undefined. If it's undefined, it usually means that you're looking at some kind of infinity as an answer, or DNE. If you get 0 over 0 when you plug in, then you're looking at something that will simplify to give you a limit that exists. It's just a matter of doing the algebra to make it work. So let's take a look at number 6. So we're going to do the same thing. Plug in the 0 everywhere you see an x. All right, so on the top, when you plug in a 0, I keep doing that. I mean, not in this class. I've just been doing it all day long. On the top, we're looking at 4 minus 4, which is 0. On the bottom, we're looking at just a 0. All right, so this is known as indeterminate. And basically, it's just a fancy way of saying you got to do some algebra. All right, you're not going to leave an answer as 0 over 0. All right, there's more work to be done. So that's telling us to do something with this expression. If your expression, your given expression, is in factored form, then unfactor it, distribute it out. If it's in distributed form, then undistribute it, aka factor it. So in this case, one thing we can do would be to distribute out the top. So limit as x approaches 0, you'd have x squared plus 4x plus 4 minus the 4 that's already there all over the x. All right. Whoa.
How'd you get that?
Oh, just FOIL.
Ah,
Yeah, this guy here.
makes sense.
Make that blue. All right. So then we have a positive or negative 4. We can cancel those away. We're looking at the limit as x approaches 0 of x squared plus 4x over x. All right. Every term has an x in it. That's nice. So kill an x. You're looking at x plus 4. Now that we've done that, I can apply the limit again. Okay. I can apply the limit again. And now I have a real number as an answer. Whereas before I didn't. So the big question when it comes to stuff like this is always going to be, how do I know I've gone far enough? Well, sometimes you don't until you apply the limit. If in this step here I plug in the 0 and I still get 0 over 0, let's say, for example, this black step here, x squared plus 4x over x, if I thought that that was as far as I can go and I didn't realize I could simplify further, I plug the 0 in, I get 0 over 0 again. Indeterminate means I can do more algebra to get a final answer. Right? If I stop there with a 0 over 0 as a final answer, then I'm wrong. Right? So algebraically, you can keep going. if you've simplified it as far as it'll go, you've done all the algebra you can think to do, and you're still getting undefined, right? So not indeterminate, but you get something that's undefined, then your limit is just not going to exist, all right? But not exist in the sense that there's no answer, or is it some kind of infinity? We'll tackle one of those in a few minutes, all right? But this stuff boils down to really algebraic skills, right? So if you have reasonable algebraic skills, you should be able to handle anything.
Is it indeterminate because it's over zero?
Because it's specifically 0 over 0. If it's anything else over 0, it's undefined. Good question.
Also doesn't work, right?
The idea being that we're not looking to use a graphing calculator, all right? So that's what you want to have in mind. There are certain exceptions to this whole idea. Basically, algebra, and only as a last resort go to the calculator if the question says analytically. And that's not really as a choice. It's not like, well, I tried everything I could, so I'm going to go use the calculator. It's more like, I did all the algebra, and I keep getting undefined. If I keep getting undefined, then that's your license to go to the calculator. But if you get a numerical value, obviously that's your answer. The other possibility is you get 0 over 0, which is the case of an indeterminate answer. That means that algebra can be done to get you a correct limit, right? And I'll show you what that looks like in a minute. But sometimes, looking at number 2, sometimes a cigar is just a cigar. Reference, anyone? Sometimes a cigar is just a cigar. Anyone?
Heard close to that cigar.
That's also one. It's actually a famous person, very, very famous. And that's the limit.
Okay.
Sigmund Freud, by the way. Was the analyzing dreams. Every item in a dream is somehow relevant, but sometimes a cigar is just a cigar. So, yeah, you could plug in the 5, and sometimes that's all you need to do. You just plug in the number, and you get an answer, and it's magical. Sometimes you could have a really hideous expression. This one's not hideous, but I mean, it's not as nice as that one. But you'll see as you work through the assignment that there are some problems that just are devastatingly ugly, like offensive to look at. And you think the algebra for this must be crazy, but it's not, because all you have to do is plug in the number and hit enter on your calculator, right? So, you know, be on the lookout for stuff like that. It'll be frustrating and then rewarding afterwards. So let's take a look at a case, you know, something kind of middle of the road, where perhaps you can't just do a quick substitution and call it a day. Like number 7. If I plug in the ones, I get 1 squared minus 1 over 1 minus 1, which is 0 over 0. All right, we call that indeterminate. Can't determine it. All right. What that means for us is it's a red flag. Yeah, it's an indicator. It's telling us that if we do algebra to this, we will get a limit at some point. All right, or we'll get an answer. It may not be what you want it to be, but it will be an answer. All right, so let's do some algebra. Things to keep in mind: whatever you're presented with, you might want to consider undoing that. So if it's in factored form, distribute it out. If it's in distributed form, factor it out. See what's going on. In this case, the numerator is very factorable. The factors are what? Yeah. Now we have that common factor of x minus 1. Meh. Kill it. That's the sound effect of cancellation. It's a nice solid meh. All right. Once you've performed whatever algebraic technique you think is appropriate, try substituting it again. Yeah, you get it too. So we get a clean number. We get a number. We get a real number. It doesn't matter whether it's a good-looking number or otherwise. It's a number. It's not 0 over 0. So now we have a limit where before we didn't. All right. Now, I'm not going to curtail your use of the calculator on the tests, quizzes, anything like that. So there's nothing stopping you from putting this into your calculator, using the graph to get a sense of what the limit is, so you'll know what the answer is. You would just need to make the analytic approach, the algebra of calculus, the analytic approach bear out that answer, short of like making stuff up, right? So you can go to the calculator, see that it's supposed to be 2, and that could work two ways. It could be really frustrating when after 10, 15 minutes you're still working on the problem and you just can't get it to equal 2. But if you look at it the other way, it's like, okay, at least I know what I'm working towards. I know what the objective is. All right, so for number 19, and this is one of the reasons why we did all that practice with rational expressions, whether it was the supplementary worksheet or the review packet. It's just because if I plug in, you could show the work if you want, or you could just think it through. If I plug in a 3 here, I got a third minus a third, which is 0, and then 3 minus 3, which is 0, right? So 0 over 0, depending on how you look at things, that could be good news or bad news. Good news, if you have a positive attitude, it's like there's hope, I can get an answer, I just have to get it. The other kind of attitude is like, dang it, I gotta do work. So, it is what it is, as Mr. McCallie would say. I don't know if he says that, though. All right, so we have fraction over a fraction.
How do you know it's 0, 0 real quick?
What's that?
How do you know it's like 0, 0?
1/3
3.
minus 1/3. 3 minus 2. All right, so I'm going to multiply each part of this complex fraction by my common denominator. Actually, I'm going to bring this down a little bit so I don't go crazy. What's my common denominator? 3x. The whole idea would be that we can cancel out all the denominators and not have a fraction over a fraction. All right, so let's get rid of this x with this one, this 3 with that one. On the bottom, we can't get rid of anything, so. You didn't have to write the over 1 if you didn't want to. I just did it to really accentuate the idea that it was fraction over fraction. All right, so 3 minus x up top. Three x times x minus 3 on the bottom. All right, so something nice is going to happen here. The 3 minus x and the x minus 3 cancel, but they cancel to what? -1. They're exact opposites of one another. So we're looking at -1 over 3x. We did some algebra. If you're comfortable with the amount of algebra that you've done, then you can go ahead and apply the limit again. See what you get. If it's real, then at least there's a fighting chance that you have the right answer. All right, so -1/9. All right. All right, so that's a case where you have to do something with the complex fraction, but then, the one below it might have been staring at you for a couple of seconds where you're like, all right, yeah, I think I can handle fractions, but what about that crispy looking radical right there? You plug in a 0 for this, what do you get? Just this guy. Radical 1, which is the same as 1. 1 minus 1, which is 0, and 0 on the bottom. So that's terrible news for a lot of us. That means you can't just throw a D and E on it and call it a day. It means you have to do a little bit of work. You're hoping not to, though. Right? So if you have a really, think of this as a binomial, even though this is kind of like a mega binomial. You have two terms separated with a minus sign. If it involves a radical, there's a single technique that you could use that'll really just make it really ugly, but then really ugly in the first step, but then really nice in the second step. Multiply top and bottom by what? You could tell me the expression, or you could tell me what the expression would be called. Big fraction bar. Very exciting. So obviously I'm multiplying top and bottom by something monstrous. What would be that monstrosity? What do we say? I heard an utterance. Same thing with a plus sign. Anybody know what that's called? The complex conjugate. All right. The reality is it's nice if you know that it's called the complex conjugate, but you obviously don't need to know the name of it as long as you know what to do. All right. So if I multiply across on the top, the whole point behind this is to get radicals to cancel out. That's why we're doing this. All right. So
Just multiply that by?
what's the name of the thing I just multiplied by?
Yeah.
The complex conjugate.
No, not the name of it. What was it? Just the opposite.
Opposite of the numerator.
This just with a plus sign.
Just the opposite.
So same expression instead of a minus, a plus.
Oh, okay.
So when I FOIL out the top, I'm going to multiply the two first terms together. When I do that, what do I get? Outstanding. I mean, it's just so powerful. 1 plus x, yeah. The outer and inner terms are going to cancel just because that's what happens when you multiply conjugates together. So then I'm going to multiply, I'm going to go purple. I'm going to multiply the last terms together. So minus, same idea, 1 minus x. Now on the bottom, still hideous. X times all this jazz. So x times aforementioned monstrosity. So like I said before, it gets really ugly quick. Oh, can't wait. It gets really ugly, but then it cleans up really nicely. Right, so 1 minus 1 is going to zero out. And then x minus negative x is going to be a 2x.
Straight into algebra.
If you go to this step and think that you should plug in the 0, you'll find out pretty quickly that that's not the right move. Because if you plug in a 0, top and bottom, you're going to get 0 over 0 again. Not a complete waste of time, just mostly a waste of time. But I do have a common x that can cancel. All right, so now I'm satisfied that I can do the substitution again, because there's no way I'm going to get 0 over 0. There's no variable in the top. There's no way that that 2 can become a 0. So I go through the process now of substituting, if I come up with undefined, then that just means I'm looking at something that's DNE. So I'll do my substitution. Wrong thing again, of course.
So can I go?
Yeah. So 2 over root 1 plus root 1. So 2 over 2, which is equal to 1. All right, so if you look at question 22, you see it's very similar to 21, so you now have a recipe for that. Some of them are easier, some of them are harder, so enjoy the process. All right, so we have a case where, and you don't have to show the step of plugging it in the first time if you suspect that it's going to be something you have to work through algebraically, but there is a benefit to doing it in some cases because you save yourself a lot of work. All right, so I'm going to plug in the 0 for the x in each case. So we're looking at 1 minus 1 over 0. So 0 over 0. That's like a terrifying moment if you don't like algebra, because that means that there's something that you can do to this that'll help you get a limit, and that something is algebraic based. So if algebra is one of your weaknesses, you're not thrilled in this moment. Right. But let's work through it together and see if we can remember something from the days of old. All right, so I'll start you off with something. I can multiply top and bottom of this fraction by something. And that something will allow me to cancel out the radicals in the top part of the fraction. Do you know what that something would be? I think I kind of heard it. What is it? What are we doing?
Like it's like the top of the
The top with a plus sign, yeah.
What's it called? I'm sorry.
Do we know what that's called? I mean, in the grand scheme of things, knowing what to do is more important than what it's called, but it would be really cool if somebody knew what it was called. I'll allow it. Oh, what is it? Now that again. Conjugate.
Yeah.
Oh, you said it? My bad. All right, yeah, so same expression, same binomial, different sign. We call that a conjugate. All right, and the purpose behind multiplying by the conjugate is to basically simulate the concept of a difference of perfect squares, which allows us, when through the foiling process, to disregard the outer and inner terms. Right, so it tells us that we can multiply the first values together, and the last values together, an additional mer. So a total of 2 mers. I'm gonna keep track of your mers. On the bottom, we're just stuck with the mess. So, look at that. Gross. With the conjugate process, you're going to end up with a big old mess, but then it's going to clean up beautifully. All right. So, simplifying the numerator, 1 minus x squared minus 1. Well, the 1 minus 1, that's easy. That's just a 0. All right. So, boom, shakalaka. So now we have limit as x approaches 0 of negative x squared up top and x squared 1 minus, or 1 plus, sorry, root x squared plus 1 on the bottom. All right. Don't jump the gun, because if you substitute too early, you'll feel like you're doing it wrong, because you're still going to get 0 over 0. If I plug in a 0 now, I mean, even though it's a little simpler than what it was, it's still going to give me 0 over 0, and I'm going to feel like probably did all that for nothing. But I can cancel. Little cancellation. Yeah, this green is not good. Hold on. Let me see here. A nice flavorful orange. That looks like mustard, really? Looks great on my screen. It's too yellowy. How do we feel about that one? Loving it? All right, cool. Ooh, is it too bright?
It's fine, it's good.
Oh, it's terrible.
We can do that? Oh, yeah, we can.
Yeah, they're common factors, so kill them. That's their reward for being common factors.
Why would it be plus radical?
Say it again?
On the bottom one, why would it be 1 plus radical? If you're able to cancel it out, wouldn't that mean that it has to be multiplication? On the bottom?
Well, all I canceled is this guy.
Yeah, and then, oh, J, never mind.
All right, so now I know that if I substitute in the 0, I'm definitely not getting 0 over 0 as a result. There's no variable on the top. I'm going to have negative 1 over something. So I'm getting an answer now. Hopefully it'll be a nice answer, but 1 plus 1, fun fact of the day, is equal to 2. So negative 1/2.